Okay, continue on, please.
Okay, so I was explaining about the node on top of a mountain not being the equivalent of a repeater on top of the mountain. Repeater on top of the mountain uses two frequencies. It transmits on one and listens on another. And by virtue of that, anybody who transmits on the input to the repeater can be heard by everybody else by virtue of the fact that they're listening to the output of the repeater. When you have a single channel node, anybody who transmits on the input will not be heard by anybody else on the other side of the mountain. So they're going to jam each other, they're going to QRM each other. And if you have multiple people at the bottom of the mountain, they will wind up jamming each other, well, from one side of the mountain to the other, the guys that can't hear each other. And then the guy on top of the mountain, since he has to hold off transmitting until the channel is clear of everybody, he will apparently not transmit at all because he's hearing everybody. And the rules are he can't transmit when somebody else is transmitting. So therefore, the node, an omnidirectional node on top of the mountain will not work well at all. It may for the first week or two after you put it up with 2 or 3 guys, but as soon as you start adding people to that one node, the whole situation is going to go downhill and real fast. And this has been proven time and time again.
So do you have sort of a rule of thumb about how many nodes we can expect to have sharing a channel effectively? It's got to be more than 2, right? Like if it's only 2, then this is really hard to be
this is hard.
Right?
This is hard to orchestrate, as you point out. You know, if you want mesh to become popular, you got to have a lot of people on. So you got to be able to handle that. So the solution is you get clusters of people who hear each other. They then have a node on that channel which feeds back to the backbone via DTD. And that backbone point-to-point link brings it to another cluster who's on a completely different channel for their local access. And then you multiply this by the number of nodes you have, or the locations, and now you start to have something that resembles a capable network.
So a mesh network is designed to have multiple nodes on the same frequency meshing.
Well, it is, yes.
By definition.
At
what point do you exceed the
saturation point?
Yeah, the threshold where you start having problems.
Well, it's probably around 3 or 4 nodes, believe it or not. And there's another thing that you have to factor in, is that the more people you have on one channel, the less bandwidth each person is going to get because everybody has to share the same bandwidth. So yeah, mesh is nice in that everybody can hear each other, talk to each other, but it's not magic. You're still bound by the laws of physics that only one person can transmit at a time. And if people can't hear each other and they both transmit at the same time, somebody in the middle of those 2 people are not going to hear anything. They're going to hear garbage. So it's a matter of physics. Mesh is one thing, the definition is nice, but that's as far as it goes. You still have to rely on radio being radio. We're all hams. We know what QRM is, and some of us probably know better than others what QRM is. So, you know, just because you're on microwave, just because you're running mesh, doesn't mean you don't have QRM. And by the way, it doesn't mean you don't have band openings either. That does happen. So,
I was going to say, Mark, go ahead.
Sorry, go ahead.
I was going to ask Mark, do you have a case study that we can look at where they publish their network in some kind of detail that we can see how they did it? Because I'm still confused about how we overcome the limitations that you're describing.
Okay, I believe on the documentation site called Read the Docs, I think there's a section on there called Network Design. Okay, I'd have to look at it to be sure, but I believe I remember seeing it there. And the way you get to the docs, the best way that I know how is when you go to download firmware, there's a step there that says documentation. So go there. AB7AW has put a lot of work into doing those docs, and they're very good. But you know, you got to stop to think about what you're doing. You know, QRM is QRM, whether it be on 80 meters CW, 10 meter FM, or 2 meters on 5.2. Imagine somebody going to the top of a hill on 5.2 and operating there all day. What would that sound like to everybody?
Mm.
It's the same thing. It's the same exact thing.
It sounds to me like we're going to end up having to do a total revamp of our idea of the backbone from White Center all the way down to North Admiral, it seems like.
Well, if you have everything in one frequency, yes, that would I think that would be a true statement.
And Mark, the analogy I made before of like, well, isn't this just the same consumer Wi-Fi that you would put in an office? And in an office, you've got 20 or 30 people all on the same channel. How does that break down?
Yeah, well, I've done some work with the Red Cross, okay, and I've been to a disaster scene once in a while. And what you see at the Red Cross location, everybody brings in their laptop so they can prepare all their reports, and they all try to use the one Wi-Fi channel that's available. And they all start complaining, I can't get through, I can't get through. So your point is absolutely true. And the same thing happens in an office. And I'd be surprised with any serious office that relies on Wi-Fi for their connectivity, because it just ain't there.
At least not without multiple Wi-Fi nodes on different frequencies,
Right.
et cetera.
Yep. And if you look there, all those nodes that you see on a distributed Wi-Fi network are on different channels.
Now, another thing, we have ham-WAN in the Pacific Northwest. That's kind of our backbone, if you will. The problem with using it as our backbone is if you connect an AREDN node to ham-WAN, you're basically using the WAN connection to do that, and you have to share WAN to extend that across the mesh that you're creating there. So ham-WAN, unfortunately, also has a link to the internet. So boom, all of a sudden we're faced with the challenges of our mesh system. If we use ham-WAN as our backbone, sharing
well, that has been taken care of with the mesh firewalls as of late. There was a recent request to prohibit people coming in the internet port from going out onto from being able to access the local node. And in fact, from day one, the firewall rules prohibited anybody from coming in on the internet port and going out on the mesh. Well, they've now given you an option to actually prohibit that action directly to that node. So that is taken care of.
Well, but that locks down using that capability. However, in advanced administration, you can enable that connectivity. So you've just bypassed that lockdown, so to speak.
Right. Now, if you wanted to use ham-WAN for your point-to-point links, well, then just set up tunnels over the ham-WAN. That'll work. You know, use ham-WAN as your backbone network. You know, why do you have to reinvent the wheel? And maybe why do you even have to compete them?
In fact, that's exactly what we're doing.
Yeah, and that will work fine.
But you need no, you don't need internet connectivity. You just need data connectivity to have a tunnel.
Yeah, treat them as an internet connection and you're done. Set up a conventional AREDN tunnel. And that will work. Now, I believe there's other people, other locations that are doing just that.
Yeah, we're doing a lot of tunneling, but right now it's on the internet. You need the WAN connection to make the tunnel work.
Right, and probably the best situation would be if you had ham-WAN at the same site that you have your mesh nodes, because then it will be a simple Ethernet cable into their switch. All right, you wouldn't even have to worry about an over-the-air connection.
Topographically, we don't have the capability to have ham-WAN at every location. For example, Tom Saunders, N70EP, and Frank McJunkins both live down in a hole surrounded by hilltops and don't have a look hardly at all without tunneling. But that's not the only one. We have we kind of like San Francisco, we have 7 hills in Seattle, and it's really bumpy jumpy all the way through. Only a few people that are on the highest hills have a good look at HamWin, and so it's impractical to have HamWin at every mesh site.
Well, every major mesh site where you have your point-to-point links and where you establish your local user channel, that's where you would put it. You don't have to have HamWin at every ham site. You have it at your major site that services a given location, a cluster, if you will.
So I'd like to suggest we could spend the whole night on this topic, and maybe we should, but I would like to suggest that maybe we, Seattle, take this into a separate meeting, separate discussion, and see how we might approach engineering, designing our build out to comply with some of these concepts.
Mm-hmm.
It's good that we know now.
Yeah. See,
Mark, could you look at the chat and see if I got the right link? I've got something called network topology. Is that in the chat?
Right, I see 3 things here.
It's the last one.
Okay, I see something from Nick, and I see something from you, John.
Okay. Yeah, there's 2 different documents. Okay, yeah. So that's probably, yeah, Nick probably has the right one. That would be in the doc.
It's the same one.
Yeah.
Yeah, they look like the same one.
Oh, they do. Okay.
Yeah.
Okay, that's just all I wanted to know.
Yeah. Now, I think the point to take away here is that you just can't set up links and expect OLSR to sort them all out, because that ain't going to happen. Okay, OLSR is the routing protocol, and it'll try to make sense out of what you give it. But if you give it garbage, it's going to give you garbage right back. So just keep that in mind. There is a certain amount of engineering design work that does have to go into this to make it work right. It's not magic.
And the same is true of office Wi-Fi too, right?
It is. And any good office that I've worked at, they do not even allow office Wi-Fi. You know, any big corporation.
Every office I've ever worked at is only
yeah.
Wi-Fi.
Well, you know, any corporation that is concerned with security, Wi-Fi is the first thing to go. The second thing to go is access to thumb drives on people's PCs. So yeah, your point is well taken. The scenarios are exactly the same, but you know, this is what happens. And Wi-Fi in an office is it may be just limited to a given floor, given a room or so. Here, you're going to corrupt the whole area of 20 square miles or even more than that. And that's not something you want to do.
I think we could also use some 5 gig for some linking, point-to-point linking, as long as we're careful what frequencies we use and where we use them in reference to where we have ham-ran receptors. So there's opportunity for us to use some 5 gig. There's opportunity for us probably to use some part 15 2 gig. Nothing says we can't use that. Again, for linking different mesh groups and tunneling. So I see an opportunity to sit down and have, you know, some complex figuring of how we can implement all of this, but I think there's possibility to do it.
No, I think on the 5 gig there is an awful lot of opportunity, even though you may have a lot of ham-ran links around, in that generally point-to-point links are directional. So I'm willing to bet ham-ran is using these as directional links also. So if you don't get in their direction and they don't get in your direction, well, maybe you can co-occupy a channel, but you're going to have to sit down and understand what their topology is. You're going to have to configure yours to match that, not interfere with it. literally, and you could be good to go.
Yeah. And a lot of their point-to-point work is on part 15 frequencies. The sector antennas to the end user is what's on the ham frequencies.
Yep. So you have to take an inventory of what frequencies they're using, keep that in mind, and if there's frequencies they're not using, well, then that may be open to you, depending on what the frequency is. They don't own 5 gig.
No, of course not. We chose 2 gig so as to just real simply avoid interference or conflict with them. However, it looks like that choice wasn't the best decision that's been made. So what we need to do now is revisit what our options and opportunities are, and sharing 5 gig with them is very, very doable. There's, it's not going to be a slam dunk problem, but it's not going to be a slam dunk okay either. So we're going to have to sit down and look at all of it. But we also need to look at our 2 gig spectrum and see what our opportunities are there. And nothing says we can't mesh outside of channel -2. We can mesh on part 15 frequencies. We've got the whole 2 gig Wi-Fi spectrum that we could use.
Yes, you do. Well, part 15 is nothing to sneeze at these days. So, look for your dedicated part 97 channels for starters. And to me, that means 5 gig, 3.5 gig, if you don't care what the FCC is about to do or not about to do. And you even have 900 meg. There are channels on 900 meg if you want to do some long haul stuff. Now, I don't know about you, but in the New York area, we have something called Easy Pass. And Easy Pass is a toll collection scheme that you put this tag in your windshield and you can drive through toll booths and it'll read your account and all that. Well, Easy Pass happens to be the primary occupant of 900 megahertz. So you can't give them QRM. And if you have toll-free freeways around, good chance that they're on 900 megs and you're going to have to stay clear of those channels. But 900 megs is there. There's equipment made for 900 megs. It works just the same as the microwave stuff. So, just keep that in your bag of tricks.
Okay. Christian, are you still moving or are you stable?
Those are like 2 different questions.
Mentally or figuratively? Carl, why don't you talk about Meshapalooza?
Okay. In following West Seattle's lead of having a Meshapalooza, a gathering whereby we can get people programmed up and onto AREDN, Seattle ECS did a Meshapalooza of their own, focused on north end of Seattle and northeast Seattle, but it was open to everybody. We had 13, I think, people show up with nodes to get programmed. All but one of them walked out with at least one functional mesh node. The one person that did not, we're still working with or trying to work with, but she's not been totally enthusiastic with moving forward. But I think it will come. But the next step, the challenge is getting those people to put their nodes up on the air and try to see if they can get any RF contacts. And so far, we haven't made much progress in that regard. So overall, the day was a very successful day in getting people programmed. Thank you to Ron who came down. Thank you to Nick who came down. Couple of things we discovered at the time of that event. The latest software was what, 3.24 or something like that. And since then, a 3.28 came out. Is that correct? The latest something. Anyway, one of the devices, the AR300M16 from GLINet, on the version of software that was available at the time of our mesh Palooza, the WAN node did not work. You had to multiplex out the LAN node using a managed switch to get a WAN interface. the latest version of software since then has fixed that. Now both the LAN and WAN ports properly work on that device. I think that's the only thing that's changed since the day we did it. So yeah, we got a dozen people up and running with mesh, with AREDN-NWMESH, but we haven't really expanded much RF footprint yet.
Okay. Nick, you want to talk about your experience at Meshapalooza?
Yeah, I mean, I think it was a great event and helped 2 or 3 people get stuff installed. I think we talked already. We had a separate meeting with Christian and Carl and sort of chatted about some thoughts. And one of my thoughts was giving more of a high level overview of like, what is AREDN and what are we trying to accomplish? And actually, honestly, I think this ties in a little bit to maybe some of the things that Mark was just talking about. And in fact, the very first, like really early on in that network topology thing, they say it's really important that you figure out what the purpose of your AREDN mesh is. And that sort of guides a lot of the thinking about what you're doing, and it also helps motivate the installation process and things like that. And so I thought, you know, maybe a little bit more sort of discussion about some of the use cases and scenarios that we want to support, even if we're not expecting those particular people to be like the frontline, you know, emergency communicators, but just to sort of get everyone on the same page sort of about, you know, what is kind of the objective here. Is the objective that we're going to have a big IP phone deployment? Is the objective that we're going to be chatting on mesh chat socially? Is the objective that we're going to be using this in emergency situations where the power goes down, and what does that mean, right? Because all of these things are plugged in the wall, right? So I don't know, just sort of some more discussion kind of about some of those scenarios might have helped a little bit, because I did get a lot of questions sort of at the end, like once people had it installed, was like, so what do I do now? Like, should I just stick this in the closet and plug it in? And I don't think that that's necessarily what we wanted, was people to just sort of install it and then shove it in the corner. Maybe we do, right? Maybe I'm wrong, right? Maybe the objective is just to get more nodes out there to enrich the mesh. But anyway, so those are sort of some of my thoughts.
Okay.
Let me comment that Nick was instrumental in getting our Meshapalooza to be a success, and I want to thank him also. And
yeah, glad to help.
Subsequent to that, he was instrumental in helping us get Mesh Chat running on the newer software with the newer version of Mesh Chat.
Yeah, I'm also totally new to all of this, and so I'm really enjoying hearing some of these discussions and seeing some of the faces involved and like getting the deployment to where it is. I mean, I don't think that we should ignore the fact that there's 600 devices that are connected right now. Through tunnels and through actual RF links. And that seems like, even if it's not the ideal topology, I think that that's a pretty big achievement.
All right. Hey, Barry, I know you've been very quiet. What did you think of the Meshapalooza? What did you take home from that?
Well, I was already set up and my TP link was programmed. So I just played around in the room, seeing who I saw, and all the RF got to my brain with having about 5 or 6 or 8 or 10 TP links and microticks and all the RF floating around. But I don't plan to have babies. So anyway, it was fun. It was great. And Mark, I'm going to put up the north and the south on my Queen Anne repeater site, and I'm going to separate them as far as I can, and I'm going to find out for myself what happened.
Okay, well, knock your socks off and report back. Maybe I'm wrong. Maybe you can get them separated enough.
So Barry, is there any building structure on the roof up there, like an elevator penthouse, where you could put nodes on opposite sides of that, so you got some building in between the nodes?
No, it's a small roof on the top of the old building. But I can get some separation, and I'm just gonna try it just for experimenting. And if it doesn't work, we'll go up, take one of them down, leave one up and deploy the other one somewhere else. But, you know, we're all on channel 2 here in the Northwest, and it sounds like we don't want to start changing our entire structure here, do we?
Not yet. Not
Okay,
until we figure out what we want to do.
Yeah, we need to drop back, I believe. It's my thought that with the help of Nick and Carl and yourself, go back and re-engineer what we think we want to do, and then go back and reflash the radios with upgrades, put them on different frequencies if that's the order of the day. All these things that we'll need to take a look at in the long haul, not something to do overnight. But I'm just trying to think here. We've got one at the Salvation Army. It's a sector. We've got an Omni at the Myrtle Reservoir. We've got an Omni at the guy in between old Doug North's house and the Salvation Army. We got mine. We've got a Admiral Brookdale. We've got Alaska Brookdale. We've got the senior center, which is totally blocked by buildings now. So there's some re-engineering we have to do anyway. So as we look forward to 2024, I think we're going to have to come up with a re-engineering of what we currently have to support what we think we might want it to do. I'm going to kick it over real quick to John Walling. John has been instrumental in doing the Zooms when I can't, because of travel, can't make it. John, do you have anything for us?
No, I'm just kind of trying to absorb what you guys are telling me. I do have to get the mesh chat working. I have to get I'm running on 1. I need to get to mesh chat 2 to find out if that's my problem. And
Okay.
Steve N7LNX has been my tunnel, so I need to coordinate with him.
Okay, and let's drop down to Steve. Steve, how are you doing down there, buddy? Haven't talked to you in a while.
Yeah, it's been a while, Ron. Doing okay. And when the recording stops, if I could talk to Mark briefly, I'd appreciate it.
Okay, we can make that happen. Mark, you can stick around. I'd appreciate it. Talk to Steve.
Okay, I'll be here.
I've got the Raspberry Pi still underneath my desk here for you, Steve. So I'll get it to you someday.
Quick comment, Ron.
Yeah, go ahead, Carl.
I can set up tunnels in the EOC node. So if anybody wants a tunnel directly into there, just email me your node name and I will email you back the information you need for your client programming in your node. And obviously you need to be internet connected or connected to HamWAN, one of the two.
Yeah, I've got HamWAN here. I've also got the Mesh Omni, and it was a thought that hooking in the smart switch that has a LAN and a WAN, that I'd be able to figure that out on my own to connect HamWAN into the mesh, but haven't been able to get that accomplished. But
I can help
down the
you.
road, maybe. Down the road, well, maybe if I buy Nick his breakfast in the morning, maybe he'll help me out. Barry, Mark, it's back to you, friend.
Okay, back to me. I've been working with Steve on bringing up something called Piwix Rix. Okay, Piwix Rix is a special piece of software that listens to the NOAA weather radio broadcasts. And it does two things with those broadcasts. Number one, it makes it into a SIP extension for a PBX so that if you want to listen to it, you call it up as an extension. And when it rings, it answers, and all of a sudden you hear NOAA weather radio coming through your phone. And this can be listened to anywhere on your telephone network. And if your telephone network is part of Mesh Phone, well, then that can be heard anywhere in Mesh Phone, which is in many states and in some countries, or over on Ham Shack Hotline, because we have a tie line over to there, so that you can go back and forth between Mesh Phone and Ham Shack Hotline. And ditto for Hams over IP. The second thing Pywitrix does, it decodes the actual weather alerts as they come down. It'll tell you what kind of alert it is and what counties are involved. And it can send that out in some sort of textual fashion. There's maybe 10 or so working around the country, and they all pretty much send out their alert messages in terms of email. And I think on Steve's server, I don't know, Steve, you may comment on this. The number of people have set up something called Citadel server. It's a groupware server, and one of the functions it does is email. Well, there is something called Meshmail that uses normal email protocols. And I have a number of these different Pywitrixes feeding into selected Citadel servers around the country. I think Steve is one of them. I'm not sure. I might be confusing Steve with the folks to your south in Oregon. But one of the things you can do with Citadel is set up a blog and enable that blog to receive incoming emails. So I've set it up so that any of the Pywitrix alerts that I get go into these blogs that are set up on Citadel. I've also been able to write some interface software that takes those emails and sends them into Mesh Chat. I have a Mesh Chat running in New Jersey that you should be able to see in your nodes list called Mesh Chat-WX. And all it does is gather these weather alerts from wherever I can get them and post them up on Mesh Chat. A couple weeks ago, Hurricane Idalia passed nearly overhead here in North Carolina. So you can imagine the NOAA weather transmitters in this area. We're very busy. We're very busy. All kinds of hurricane alerts, tropical storm warnings, severe thunderstorm warnings, lightning, flash floods, and they're all on Mesh Chat if you want to dig down far enough. So they're all there if you want to look at them as a historical thing. I think I have them going back for a year now. So that's what we've been working on. Steve's been having a little difficulty. I think it has to do with Linux more than anything else. So I've been working with him and trying to walk him through getting this up and running. So that's what I can report on this end.
All right, Mark, thank you. Stick around because I think Steve wants to get you after the recording stops. Try one more time for Christian. Christian, are you there?
Hey there, guys. Yes, I am. Sorry, I was muted because I was in the car on the way home and popped in the grocery store. This has been super helpful, and it'll be great. It sounds like Nick asked exactly the question I had, Mark. Mark, everything you said has been really, really helpful, and basically figuring out what some of the use case examples are out there. And if I understood, if I heard correctly, I think Mark had said, go back to the AREDN documentation, and there's some material there. So it sounds like that's where we should start. But again, thanks so much, you guys. Thanks everyone for the help getting us set up in the Northeast sector. And Mark, thanks for sharing your knowledge about AREDN.
All right, Christian, thank you. Anything for the good of the order before I stop the recording? Hearing once, twice,